Hello, everyone. Welcome to this talk on observing Elasticsearch clusters using the Elastic Stack. I'm Vinod Iyer, and here's a quick intro about me. I'm an observability and telemetry enthusiast with deep expertise in the Elastic Stack. I recently became an Elastic certified engineer, and here are some of things about me. I'm a senior engineer at an awesome gaming platform company, and I started working on the Elasticsearch, Logstash, and Kibana back in 2014. Some of my accomplishments include seeing my Kibana dashboard work show up on a local television news. And I was also fortunate enough to be one among the 4 finalists of the Kibana dashboard contest. For those of you who may have noticed the description of my talk on the community conference website, there's a mention of a call sign Kibana Man. And I picked that up from a random conversation with a gentleman named Kevin Keeney at Elastic during a local user group meet in Atlanta back in 2017. Now let's move on to the topic at hand, which is observing Elasticsearch clusters using the Elastic Stack. But before we dive into the topic itself, here's a background on how I went about reaching to the solution itself. And it begins with a tale of a Friday night PagerDuty alert. For those of you who operate Elasticsearch clusters in production environment, I bet you'll agree with me that a Friday night PagerDuty alert has nothing cool associated with it. So here we were, myself and a colleague of mine on a Zoom call late night on a Friday, trying to fix a broken Elasticsearch cluster. And sure enough, within the hour, we got the issue dealt with and the cluster was back to business, and we called it a night. But observability is something that's very close to my heart. Even if I see a very minuscule gap in observability, I start thinking, hey, could we have had that last trail of data point visualized in a near real-time observability solution, possibly in a single pane of glass? So I asked the same question after this late Friday night incident. What did we do manually after getting on that call, which our observability systems couldn't provide at the time? And one thing that struck me was we did in fact look at the nitty-gritties of many cat and cluster APIs. Now, could we have had the same data points at the same resolution on the tip of our fingers in something similar to Kibana, if not Kibana itself? Then it dawned on me, the observability idea. Well, the cat APIs and the cluster APIs are nothing but REST APIs. And I suddenly remembered an Elastic's blog article about the HTTP poller input in Logstash. And voila, there you have it. Basically, the idea is polling cat APIs using Logstash. So here on screen, we see a sample block of Logstash configuration file, which is part of the ingest of the solution for observing Elasticsearch clusters using the Elastic Stack. As you can see, we start by chasing some cats. And first up is the allocation cat. And the HTTP poller block has no complications. It's pretty straightforward right off the documentation. It just has a URL and the credentials to hit, let's say, an Elastic Cloud endpoint with JSON headers and a request timeout of 60 seconds and a cron schedule for repetition. And the codec used is JSON. Now, the trick here is you have to decide beforehand how you're going to visualize this data. And a key element for visualizing the data and segregating it would come down to the tags that you see here. What I chose were 3 pivots, which is environment, cluster name, and API. So all my Kibana saved objects are based on or pivoted on these 3 elements, which environment is my Elasticsearch cluster running on, what is a cluster, and which API is giving me the results. Now, in order to visualize the data retrieved from the CAT APIs, a minimum level of transformation or cleansing is required using mutate filter, namely the rename and convert. Renames to rename the fields with dots and change them to underscore, because Elasticsearch automatically detects fields with dot or considers field names with dot as hierarchies, which will cause problems. And conversions of fields like disk percentage, heap percentage, etc. to integers, so that we can visualize them using, say, metric aggregations like average, percentiles, etc. Now, I have to call this out that this is not the optimal solution for this idea. A more optimal solution for me would be enforcing a strict Elasticsearch template at ingest, which would potentially help in optimizing on the storage requirements for this index as well. Now, once we have this ingest to Elasticsearch, it's time for some Kibana magic. With the rich data from the CAT APIs and the cluster APIs, we can have some magic from Kibana, like the one you see on screen, which is an Elasticsearch cluster analysis dashboard. In a nutshell, this answers quite a lot of questions that may come to an engineer's mind who operates Elasticsearch cluster in production or dev environment. Basic things like the health of the cluster, or what are the different types of nodes in the cluster, or the resource utilization, and so on and so forth. Again, we'll jump into the low-level details of this dashboard during the demo time, but rest assured, this dashboard has helped us many a times during the production issues after the solution was implemented. Now, one of the thoughts that have come across my mind is related to the cluster state of an Elasticsearch cluster. I always think, hey, is there a way for me to look at the historical state of my clusters and compare it to my current one? And sure, if you have platinum license or enterprise grade license, the auditing feature there would make that job pretty easy. But what if I'm running my Elasticsearch cluster on open source distribution, or I'm leveraging basic license, which does not provide auditing to me? Well, then it hit me. For cluster audit, you basically need information that the various underscore cluster endpoints provide underscore clusters slash settings, and so on and so forth. And it is nothing but just another REST API. So with a couple of more HTTP polar inputs in Logstash, I was able to build a Elasticsearch clusters audit dashboard. And this basically has the historical values of the various clusters, state values or cluster settings, etc. Again, this is completely customizable, and the charts here are based on the current Elastic Cloud instance that I use to facilitate the demo that I'm going to exhibit. But depending on the specifics of any Elasticsearch cluster, you can build your own charts and get the richness of the perspectives that Kibana provides. So with that, let's move on to some demo, shall we? In this demo, we're going to look at 7 different Kibana dashboards, which gives us a trickle-down perspective, top to bottom, on, let's say, a fleet of Elasticsearch clusters, starting with the fleet itself, the basic health of the fleet of clusters, and then diving into each and every granular level, like at a cluster level, at a node level, at an index level, and things like an audit of the cluster state, and a cat corner, and a node attribute analysis at the very end. So what you see on screen right now is an Elasticsearch clusters overview dashboard, which, as the name suggests, provides an overview of the various clusters or a fleet of clusters that you're running. The first chart is nothing but the health of the various clusters. And for this demo, I have 2 different Elasticsearch clusters running on Elastic Cloud, and I ran Logstash on my local to hit the cat and cluster APIs of both the clusters and ingest that data into one of the clusters. The Kibana that we see on screen is the Kibana fronting that cluster, which is ingesting the data, the cat API data of both the clusters. So as you can see, the health of the clusters were pretty much green, except for the initial yellow for the second cluster. And right below the health is the CPU usage by cluster. And when I say CPU usage by cluster, the plot here is the average CPU usage across the various nodes of a cluster, across both the clusters. Next is heap memory usage by cluster. Again, the average across various nodes of the clusters. And below that comes the disk usage. Please note that I didn't have any data ingested to both the clusters except for this monitoring data to one of the clusters. Hence, the disk usage is almost 0 all the time. And last but not the least, some gauges for the CPU utilization and heap percentage, so that visually you get a sense of range of CPU values. So that's pretty much Elasticsearch clusters overview dashboard. Now let's say you want to look into one of the clusters in your fleet in detail. That's when you move into the cluster analysis dashboard. So here this dashboard is filtered for cluster 2, which had a yellow state. And this dashboard gives quite a lot of perspective into a single cluster's health and state of operations. So outside of health, you can see the average number of documents by the index, which gives us a sense of distribution of number of docs across the indices in the cluster. Next up is nodes by number of nodes by type, as in how many total nodes, how many master nodes, how many data nodes, how many ingest, and how many coordinating only. The next step is a 2-layer pie chart with the cluster name and the various nodes in that cluster. Remember, we saw average CPU utilization, heap usage, and disk usage across clusters. So same idea here, but since this dashboard is meant to be used for a single cluster, all the plots are by node. So each line represents a single node in the cluster. And we have 3 nodes in this cluster, so 3 lines. And the same gauge that we saw in the Elasticsearch clusters overview are present here as well for a quick blink of the eye check on the average across the cluster. This dashboard also has the additional plot of average load, 1 minute, 5 minute, and 15 minute by node. And the very useful number of shards in the various states, shard states like started, unassigned, relocating, and initializing can also be seen here in these metric visualizations. Now, in my experience, many an engineering team overlooks the thread pools and the pool usage. So that's why I have 4 charts dedicated to thread pools here. Active and queued threads by node are the first 2, and active and queued threads by the thread name itself are the next 2 charts. We also have the node attribute count by node here, as in number of node attributes for each node, and some visual representation of the indices with their average number of blocks. So that's pretty much the cluster analysis dashboard. And in lieu of the limited time that I have remaining for the session, I'm going to hop through the next dashboards relatively quickly, but do post in any questions via chat or otherwise if you have any. So once we look at a cluster itself, we may have the urge to look at a specific node depending on the situation at hand. And that is where node analysis dashboard helps us. So what you see here is something very similar to what we saw in the cluster analysis dashboard. In fact, the only additional visualization here is index by shard by state. So from inside outwards, the various index names that reside in a node and the various shards and the state of the shard, started, unassigned, etc. And you also have an additional table here, which is node attributes, which is an easy way to export out the attributes of a specific node in question if there is a need to share that via Slack or any other instant messenger to your team. Do notice that the node selection filter is a Boolean query, and this is necessary because the reference to the node name is slightly different across the various cat or cluster APIs. Now, moving to index analysis. Let's say you want to analyze a single index in an Elasticsearch cluster. This is the dashboard for that purpose. Right now I have .security-7 index filter applied on this dashboard. And basically we see the average number of documents in that index. And the security index has 1 primary and 1 replica. And shard 0 is started right now. And this is an interesting chart, especially if you have a big cluster and your shards of your index are spread across the cluster. Basically, this heat map visualization shows the various shards of an index across the various nodes that you have. So for bigger clusters, you'll see an elegant distribution across the various nodes assuming the shards are evenly distributed across your cluster. And again, for people who like numbers more than graphs, you have the tables here. Next is an audit dashboard that we slightly touched upon previously. So the audit dashboard basically has a timeline audit of, let's say, cluster routing allocation enable, which is one of the cluster properties that exists on a vanilla Elastic Cloud instance that I'm using. Next up is node attribute distribution by attribute value and node name. So again, inside out, let's say xpack installed is the attribute name and value is true across all the 3 nodes in our cluster, the instance 0, 1, and the tiebreaker. Next is node attribute values, node attributes by value. So the various node attributes and their values as a histogram, vertical bar chart, and another heat map which shows name of an attribute versus its value with the number of nodes shown on each element of the chart. Again, you have the whole cat node attributes value shown as a table here, which can be readily exported if need be. Next is a cat corner for people who like cat especially. So this is a single pane of glass for all the cat APIs that have been incorporated in my solution. Again, before anyone calls us out, I do not know why cat field data is not showing any data. I haven't run that down, so if you'll excuse me, but definitely there has to be a typo somewhere in my Logstash config or otherwise. But the whole idea is instead of hitting multiple cat APIs, even conveniently using the dev tools in Kibana, an engineer can just come in here and look for what's going on in a cluster. And last but not the least, a node attribute analysis. So the thought behind putting together this dashboard is, let's say I want to compare various clusters in my fleet, let's say cluster 1 to cluster 2, and look at the various node attributes and the number of nodes in each cluster that have that attributes easily. This is where I would come to do that. So the first chart is a heat map which shows cluster 1 and cluster 2, the various node attributes and number of nodes which have those attributes. So cluster 1 has 3 nodes, cluster 2 has 3 nodes, both of them have availability zone node attribute set. And again, node attribute count by cluster. So each cluster has 7 node attributes. The moment something changes in one cluster, let's say a node attribute is taken off or added, this histogram would readily pop that information up here. And to export the data out for any reporting purpose, you have this table right here. So that's pretty much it on the demo. Now back to the slides. Now to quickly wrap up this session on observing Elasticsearch clusters using the Elastic Stack. We saw the demo of all the 7 dashboards, and I hope all of you find it useful at some level or the other. So at this point, I'd like to try to answer any outstanding questions that I may not have answered via IM. And if there's no other open question, a big thank you from me to each and every one of you who took out 25 minutes of your precious day to see me talk about observing Elasticsearch clusters using the Elastic Stack. And a huge round of applause to Elastic and especially their DevRel team for organizing such a global event for the very first time. I think this is a trailblazing beginning of global user communities for the open source world in general. So hats off. And with that, this is Kibana Man signing off. Till next time. Thank you.